Okay, so today we will continue with chapter 9. So this chapter 9, partial differential equations. So today I will start with the parabolic PDE. The example of parabolic PDE is heat equation. So the heat equations, today we will start with the explicit finite different methods. Okay. If I'm too fast, okay, if you cannot tak sempat nak kejar saya, so let me know, okay? So, okay, in this chapter, we will have, okay, these are the topics that we'll cover in your syllabus. Okay, chapter 9 PDE. So PDE, partial differential equations, we have three categories of partial differential equations. And the first one is parabolics. Okay, the example of parabolic is heat equations. So this heat equation we can solve using two methods. The first one is explicit finite different methods. The second one is implicit Crank-Nicholson method. And for the second category of PDE, that is hyperbolics. So the example of hyperbolic is wave equations. So the wave equation we can solve it using a finite difference method as well. So elliptics is the third category of PDE. For the elliptic, the example, we have two examples of equations. One is Laplace, another one is Poisson. So both of them will use finite different methods. So even though if you look at here, actually, sebenarnya ini tak ada. This still using explicit, but this one is just finite different method. So the first one, heat equations, we can use finite different methods. A wave will use finite different methods, and even elliptic PDE will use finite different methods. Only this heat equation we can use another method, implicit, that we will cover in your syllabus. Actually, in PDE we can use many methods. Okay, not only finite difference method, we still have other finite element methods, wavelength, and etc. Okay, ada yang nak masuk ke sekejap? I'm not sure because I already set auto emit tapi tak auto emit lagi. Di kadang-kadang saya pun pening dengan ini. Okay, so before we go very further on partial differential equations, okay, I explain to you. Macam pening, ada pening tak? Apa beza ODE dengan PDE yang sebelum ni awak belajar? Any of you can answer or not? Aizat, what you learn in the previous chapter, chapter 8? ODE kan? Agak-agaknya what is the difference between ODE and PDE? I think that you learn in your math engineering or calculus before. Ada Ahmad Aizan, are you here?
Yes, I'm good.
Are you still remember what is PDE? What is the difference between ODE and PDE?
To be honest, I don't quite remember.
Apa?
I don't quite remember actually.
Okay.
Sorry, doctor.
Okay, from time to time I will call the name, okay? So nanti kan janganlah awak tertidur eh. Okay, so I explain to you differential equations first. You know. Yep. Sekejap eh. My pen is not working now. Sorry. Wait 1 minute. I tried again. Oh, it's not working. Wait Okay. Sekejap. What happened with this one? Wait My pen is not working. Sorry, class. Give me some time. I try it again. I'm not
It's
sure
okay, doctor.
what happened to this one.
It's fine, doctor.
Wait else I have to use another one. It's another pad. Alamak. Okay. Yeah. Oh. Tak dapat. Yes. Is it need to wait? I check back. Do I need to reconnect back this one or not? What is this? Connections. It should be like wait. Class. What is this? Bluetooth. Bluetooth setting device. What is a pen? Pen. Is it this one? System, Bluetooth and devices. Uh, my pets, my pen. Is it this one? It's not working now. Pair the pen. I have to pair the pen. Let's try again. Jap. Tak dapat pair pula dah. Because I just changed the battery. Battery 4A. Saya tak pernah lagi tengok battery 4A. Well, give me 2 minutes. I change to others. But battery 4A tak apalah pula. Saya cari merata tempat. End up have to bought from Shopee. Because I cannot find 4A punya battery. Sorry class, I have to change to other device. Give me some time.
It's okay, doktor.
Kalau ubah kepada ini cuma saya punya tulisan akanlah teruk sikit lah. Because dia punya sensitivity a bit different. Okay. So, okay, we go to this one. Oh ya, tulisan tu tak biasa saya guna ni. I'm sorry. Class. Differentiations lah. Sekejap ini yang susah tu. Saya type je lah kan. I type. Sometimes a bit can be. Okay. Differential equations. Okay, we have two types. Okay, the one that you learned in the last chapter is ordinary. Differentiation equation. Okay, ini ODE. Kan? So this one, we have initial value problems. Okay, you learn in. Kalau di sini kita ada. Here we have one is initial value problem kan. And another one is boundary value problems. So, apa yang ada last time you learn is actually kalau biasanya example of the equations can be like this, right? Okay, wait. Ataupun we use is dy dx. Okay. Or we can use also this f prime x. Okay. So, definitely just normal example of the equations. Okay, biasanya macam ni. Where the dy dx, we find the dy dx. Normally we have a dy dx. And the x here is independent variables. And this is, why is the dependent variable? It will depend on x. Okay, semua apa yang orang tengok sebab ni. Kita tengok mana yang adalah what variables is independence is awak tengok yang bawah tu dx. So x tu adalah independence variable. So y ni akan berubah berdasarkan perubahan x, right? So y here is dependent variables. Okay, kalaulah ODE, that mean kalau tengok sini, we only have one variables, independence variable. We only have one. Independent Okay, variables. Okay, and we can have one, or it can be more than one dependence variable. Any ODE. So, last chapter, what you learn is like this. Okay, for example, when we are solving the initial value problems, dia kan macam ni. Let's say, for example, you have x naught, you have x1, right? X2, and so on until xn. Kan? Kalau initial value problems, that means the value of y naught is given, right? And that means that you have to find y1, y2, and so on until yn, right? If let's say boundary value problems, that means the yn is given. This one is given as well. So we only need to find this value. Okay, so we find in one direction, 1D, one dimension saja. Okay, in 1D. So the here kalau if let's say PDE, the difference between this ODE and PDE. Alamak, sorry. Now we go for the PDE. So PDE. So PDE normally, okay, sebelum ni ODE we use y prime f prime ataupun dy dx. But in PDE we normally use u. Kita guna u. Ini u So the u and let's say this one. So normally we say this is a del u, del x ke, or it can be, the equation can be del square plus with del sama dan ni example of the equations lah. So that's mean look at here. Here, these two, x and y, is actually, this is the independent variable. Independent variable. So yang ni yang adalah dependence variable. So u will change due to changing of x, and u also will change due to the changing of y. Okay, so and the symbol here we will not using d, kita akan guna delta punya symbol kat sini. Delta sini, del, nampak yang ni saya delta punya simbol. So kita tak guna dia punya simbol D lah, because D over dx, that means the change of something. Let's say just now change of tadi adalah y. Y it changed solely based on x, but this one partial differential equation, that means the u will partially change because of x, and u also will partial change due to y, and this one u will partial change due to x and y. Boleh. And so this one, how we call it is actually, yang contoh yang ni kan, kita panggil dia partial differential, partial derivative. Kita boleh panggil partial derivative of u respect to x. So in this one, that means second derivative. Kalau yang ni second partial derivative of u respect to y, and this one is second partial derivative of u respect to x and y. Nampak? Dia ada dua independence. So the PDE, that mean it can be have two or even more than two independent variables. Okay, and it can be it can have one or even more dependence variable. I'm sorry that Awak tengok tu macam pening tulisan tu. Okay. So far okay class? Hide it. Okay or not? Hide it mustaqim.
Okay, Doctor.
Okay. So, okay, just now I mentioned that just now we solved the ODE in a 1D, one direction only. Kalau PDE, okay, in your syllabus, we will use two variables. So that means we will solve it in two-dimensional, 2D. So kat sini, if let's say I give the example based on this one just now, wow. Yang ni kan, we have X and Y, independent variables. So that means, kat sini, we will have something like this. Here is X, and here is Y. So here, maybe start from X0, X1, and so on until Xn. And this one is start from Y0, Y1, Y2, and so on sampailah S until Yn. And we will have to find the value on here. Tengah-tengah ni. Semua ni. Semua value kat sini. Sini. Here. Semua ni. So let's say here. So normally we will use like this one, we will use U. Tadi kan saya kata we want to find U. So here let's say this one, U at X is 1, Y is 1. Okay, kalau sini, let's say here. Let's say this one is let's say this one is X2 kan. So that means here will be U2 1. Boleh? And this is U1 2. Maksudnya the in front is the X, coordinate kat X, and the second prime comma macam ni. Kita akan letak Uij, di mana for the paksi, untuk paksi yang X ni kita akan guna use a symbol I, and here we will use J. Okay. And one more thing that sometimes you will see that we may not write del U, del X. Kita tak tulis. Kadang-kadang kalau ada, kadang-kadang orang nampak macam bukan, dia tulis macam ni. U prime. Sebenarnya U prime is same lah actually. Sama dengan U subscript. Ini X, UX. X tu kecil. Okay, so that means this one is del U, del X. Okay, partial derivative of U respect to X. But U prime ni, it can be like this as well. U, Y. Dia boleh del U, del Y juga. Partial derivative of U respect to Y. So in PDE, we seldom use prime. This symbol. Kat ODE biasanya kadang-kadang akan ada Y prime macam ni kan. Ataupun kadang-kadang F prime. Okay. Because that one is based on solely on one independence variable only. But this one, because we have more than one, so we normally we won't use this one. If let's say U double prime, so U double prime, it can be UXX. Saya tulis macam ni lah senang. Okay, so UXX, that means second partial derivative of U respect to X. And U double prime also can be U YY. That means second partial of U, second partial derivative of U respect to Y. Respect to Y. And it can be also UXY. That means second partial derivative of U respect to X and Y. Boleh tak? So we can use either dalam in the dia punya form macam ni, del ni, ataupun UXX, UYY, UXY macam ni pun boleh. Dia guna dia punya subscript. Panggil betul tak? Dalam words tu, subscript. Okay. Now, we continue with yang ni basic. Okay, ini boleh what is the difference between ODE and PDE? Okay, so ODE that you learned in the previous chapter, the initial value problems, boundary value problems, and now we go to the PDE. What is the difference? Because the difference is PDE, we have more independent variables. Okay. And the symbol, sebelum ni kita guna Y prime, F prime, kat sini kita akan guna U. Okay. And sebelum ni, before this, we use divide dx. Now we use del. Okay. Del U, del X. Okay. So we go to this. Okay. Before I go to this one, explain to you this one, heat equation, dia punya kategori. I explain to you, apa dulu Oh, okay, no. Kategori dulu. Saya pun dah pening. Saya punya ni tak boleh function and then I will become like, okay. How just now I already mentioned, right? We will have 3 categories of PDE: parabolic, hyperbolic, elliptic. Class okay or not? So far boleh? If I'm too fast, you let me know. Okay, so macam mana we want to classify this PDE? Okay, so we can classify based on its dia punya ni. Saya rasa I guess that you ada pernah nampak this equation before. B square minus 4AC. Ada pernah nampak rasanya agak lah before this? Pernah nampak? Okay. Macam pernah nampak kat mana kan? Okay. So let's say we consider this is the linear second order of PDE. Okay. This is a second order, sampai second order. So in your syllabus pun sampai second order sajalah sebenarnya. Sekejap, saya buka buku dulu. Saya pun kena tengok buku juga. Sekejap I open the note. Find the note first. Where is my note? Suddenly cannot find my notes. Ini ajar kelas lain, saya macam stress sedikit. It's not my class. So kalau my class saya cakap je lah kan. Nanti awak cakap, Dr. Tok ajar kita orang macam ni. Rupanya salah. Habis lah saya. Sekejap. I open the textbook. Okay, let's say we use the second order linear. Saya tulis lah. I write here. Besar sikit. Saya kena besar sikit. Lepas tu tulis tu jadi senang sikit. Let's say we consider this PDE. The second order, cantik sikit. Second order linear PDE. So with 2 variables, okay? With 2 variables, X dengan Y. Okay, ini contoh, okay. Ini contoh, we have independence variable X dengan Y. So kalau awak tengok this one, okay, this one we can write in this one. Kita boleh tulis A sampai second order, right? That mean second derivative, okay? So that mean second partial of U respect to X, second partial of U respect to X and Y, second partial of U respect to Y. And this one is partial derivative of U respect to X, partial derivative of U respect to Y. Lepas tu yang ni yang bukan beza punya, and normal tak ada beza, so equal to G. Let's say this A, B, C, D, E, F, G ni, these are constant, okay? These are constant. So let's say this one constant A kat sini, B, C. Okay, kalau lah B square minus 4AC ni kan, if let's say equal to 0, kita gantikan nilai sini. A, this one. Let's say sini. This one is constant. It can be positive value, can be negative value, it can be some another mungkin some constant lah. Okay. So kalau sini, yang ni A, B, C, yang ni silap D pula. So kita gantikan B square minus 4AC. If let's say we get 0, that means this is parabolic PDE. Okay. So the example of parabolic is heat equations. Okay. And then if let's say B square minus 4AC more than 0, that means this is a hyperbolic. And then if let's say B square minus 4AC is less than 0, that is a elliptic PDE. I give you example. sebelum kita pergi ke sini, saya give example untuk example of this category of PDE. Sekejap, cari example dulu. Kemana? Kertas saya hilang lah pula. Sorry class, I cannot find my note. Wait I find my note first. Kemana? Tak ada. So never mind. Let's see this one. I give any. Okay, let's say we have a root, and then we hit it at the one of the end here. Kita panaskan dia kat sini. And then we want to know the temperature. Start with the temperature. Ini T0 kan, sampai ke sini. Temperature kat hujung sana. Okay, temperature kat hujung sana. At a certain time. Okay, maybe after 5 minutes. Let's say this rod have like length of L. So let's say we want to know the temperature. So let's say okay, cari dulu. And let's say the heat, okay, and the equation katalah macam ni. The equation is like this. Let's say del T, this one, this T is temperature lah, that's mean, and equal to K. Let's say K is any constant lah. Second partial derivative of U, bukan of U, of T lah. Respect to K. Okay, kalau tengok sini kan, okay, tadi saya cakap how we identify what is independent variables. Ingat lagi tak? Tadi saya cakap, kiranya kalau lah yang bawah tu, ini kan, over del T tu kan, so that's mean T. Sekarang del K. Okay, these two are independent variables. These two is independent variable. Okay, maksudnya here, the temperature, okay, the temperature of rod will changing based on time T. Kat sini time T. Satu lagi based on K. K tu depend lah apa. Mungkin K is like mungkin dia punya kepadatan that's rod, type the material. Okay. So can be this one. So kalau lah saya refer these equations, let's say I refer this equation. Sekarang kan saya refer this equation to the equation yang atas tu. Yang ni, tengok, boleh tengok. Sekarang yang tadi ni, this equation yang tadi dia adalah respect to X and Y. Sekarang adalah kita respect T and K. Ke saya sepatutnya bagi contoh yang X dengan Y juga. Okay. Now, you look at here, what is A? Kalau tengok sini, A is something that's second derivative respect to one of the independent variables. Kat sini ada tak? Ada kat sini? Kat sini nampak tak? This one. Second derivative of T. Ni kan, second partial derivative of T respect to K. So, yang ni kiranya A saya adalah this value. This is A. Boleh faham tak? Okay, okay. Boleh faham Okay. So, saya punya ni, okay, B ada tak B? Respect to, kalau ini respect to T and respect to K, ada tak? Second partial derivative, second partial derivative of U respect, T respect to T and K, tak ada kan? Tak ada. C ada tak? C ada tak? This equation. C ada tak?
C ada kot.
C mana? Yang mana C? Yang ni dah jadi A? Yang ni dah jadi A?
Tak ada.
So C, we don't have C actually. Okay, kejap Saya mungkin ada yang blur ke? Like let's I write in this form yang macam yang atas juga. Kejap. I write in this form. Saya tulis. So that's mean this one. K del yang ni del K square sama dengan kosong. Okay. So kalau tadi kan yang ni kita anggap this one is A. So kiranya A adalah K. Tadi katanya B tak ada kan? Sebab B dia kena respect to T. Maksudnya dia sepatutnya macam ni. So kalau yang B kiranya di B dia kena macam ni. Kita tak ada dalam ni kan? Tak ada. This one here we don't have. Tak ada kan? Kat sini tak ada. So that means B is 0. C ada lah. C adalah respect to K and T. Tak ada kan? C maksudnya dia kena macam ni. C is something that should be ada. Kat sini tak ada kan? Maksudnya C kosong. Tak ada juga. Boleh faham tak?
Boleh.
Alif faham Alif? So sekarang kalaulah saya guna formula B square minus 4AC, that mean B adalah kosong sebab tak ada. Minus 4, A is K. C
0.
C is 0. So that means this is 0. So this is a parabolic PDE. Boleh tak? Boleh faham? Macam mana kita categorize kan? Okay, so now let's say I go to the terus saya pergi wave equation ni lah. Okay, right? Okay, kalau awak tengok kan, equation this one, wave equation. Dia ada, this is the wave equation. So yang ni A berapa? This one. A dia berapa? Mana A? This one lah, sini. Satu lah kan?
Satu, betul.
B? Ada tak?
1 over C square.
Negative 1 over C square.
Oh, yang tu C. Yang B sepatutnya B adalah respect to both. Ni macam ni.
Kosong.
Del X, del Y. So B tak ada. B is 0. That is C yang tadi kat sini. This one. Negative 1 bahagi dengan C square. That is C. So kalaulah saya guna formula tadi, B square minus 4AC sama dengan B kosong minus 4A adalah 1, C adalah 1. So C, katalah C. Let's say C is negative. When we square, it become positive. So here, negative 4. So that means dia akan jadi negative. Kan? It become negative value. That means less. Betul ke? Positive. Sorry.
Positif.
Positive. Sekejap 4AC.
C negative 1 over C square.
Oh, okay, sorry. This is negative So negative here times negative here. Dia akan jadi positive. Yang ni akan silap. So macam mana pun dia akan positive value. Sebab yang ni dah negative times negative. So anyhow it will become positive value. That means it will larger than 0. If larger than 0, that means this is a hyperbolic.
Boleh, yeah.
Okay, boleh. So sekarang boleh. So kalau untuk ellipse, kau tengok kalau so ellipse, that means B square minus 4AC is less than 0. If you look at this one, Laplace equation, go to Laplace. So this one is, A is 1, betul? C is 1. Okay. So saya ke mana pula ni? Sekejap, saya padam balik boleh? So So this means this one is A is 1, B is 0, C is 1. So B square minus 4AC mana sama dengan negative 4, 1, 1. So become negative value. Negative 4 kan? So this one is less than 0. So less than 0, that means this one is elliptic. Sorry. Sekejap saya dah tergerak pula. Okay, so this one, elliptic. Okay, so this is how we categorize the PDE. Okay, kalau lah, if you look at here, saya padam semua ni. Okay, tak, bukan padam, saya select and copy. How I'm going to select this one? Let's say, I want to copy. Copy yang lain masuk. Oh my goodness. Tak keluar. Apa? Ramai. So kalau lah tengok saya zoom masuk sikit lagi. Kalau tengok sekejap. Tergerak sedikit. Sekejap. Wait. Okay. Kalau tengok sini, here you look at here. The parabolic heat equation ni kan, if you respect to x and respect to t, okay? Okay, hyperbolic is respect to x, respect to t. That's mean independence variables. Okay, for the elliptic, the independence variable is x and y. Okay, so awak ingat tadi when I mentioned just now, when we want to solve the PDE, that means we want to find the value in 2D dimension. Kan? Satu x. So satu lagi untuk parabolic and hyperbolics, dia paksi y. The y-axis will be value is t, is not y. Cuma elliptic saja Laplace equations and Poisson equations, the value here is will be y. Boleh faham tak? So kalau dia macam ni. Okay, so yang ni cuma untuk elliptic sajalah. So untuk parabolic dengan hyperbolic, nanti apabila we want to find the value, that means the x-axis is x, y-axis is t. Respect to t. Boleh?
Boleh.
Okay. Saya ambil page line. Tak dapat nak copy Tak ada copy lah. Okay, saya copy and go to another page. Sebab saya pun dah ada pening. Okay. So, Amir Irfan, okay ke awak? Saya panggil nama nanti.
Okay, Doctor.
Okay, so now we start with the this one. Before we go to the further, I want to inform you how we are going to do the. Sebab kalau awak tengok syllabus, both all three this PDE, three category of PDE, we can solve using finite different form. Kan? Finite method kan. So that means daripada formula kat sini, heat equations or wave equation or Laplace equation or Poisson equation, we have to change into finite difference form. Jenis yang finite different form. So, okay, now I want to explain to you macam mana ni. So, kalau sini, remember just now I said that now we are going to find U. Katalah, let's say I use like parabolic dengan hyperbolic because it's respect to t. Okay, let's say I want to find the value of u. Dia akan ada macam ni. I draw. Saya lukis. Ni kan, tadi saya cakap, I will find this one is x and this is t. Okay, so kat sini, we start with the x0 kan. x1 kan. x2. And so on. Where is dia punya step size adalah sama. The step size is same and continue until lah, katalah saya guna another terms pula, boleh. That means saya guna x I minus 1, yang ni xi plus 1. Saya guna term I use I kat sini. Di mana setiap ni dia punya step size we can use h. Ataupun that means the step size is actually x plus 1 minus xi. Ini boleh. Setakat ni boleh faham. Ini okay. Now the y-axis we will start with t0, right? And then ini t1, okay? And then t2 and so on until, let's say I say this is ti minus 1, this is ti, and then this one is ti plus 1. Boleh. So kat sini, sorry, I pula dah. Silap. J. Sebab kat sini, here I use I. Paksi X saya guna I, paksi Y saya guna J. So this one is TJ minus 1. Lepas tu point seterusnya TJ, and this one is TJ plus 1. Boleh tak? Saya lukis macam ni. Katakanlah this one kan. Yang ni adalah I. Ini I minus 1. Yang ni I plus 1. Untuk X. Lepas tu kalau untuk Y, saya akan ada, sorry. Kalau ni, this is J. Yang ni J plus 1. And kat sini adalah J minus 1. Boleh? Okay, if let's say, boleh ke? Are you okay, class? If you not understand, then you type X. Not ein. If you understand, then you type 1. If you not understand, then you type X. Class, are you with me? Okay. Okay, thank you for your response. Apa tu Aizan? X ataupun X? A S1 ataupun X? One or half. Okay. So now actually, okay, let's say at this point kan, saya letakkan sebagai U lah. Okay, because U is the value that I want to find. So U here is U1. U1, X dia 1 and T, katalah sini. T dia pun 1. Okay, at this point, kata at this point kan. This point, this is U, 2, 1. Boleh? Okay, let's say at this point, this is U, 1, 2. Boleh? So kalau lah, yeah, this one, that means this is U, I, J. Kalau lah saya turun satu step, U, I, J minus 1. Kalau saya naik satu step lagi atas ni, let's say daripada sini, kan, U, I, J plus 1. Okay. Katalah saya datang ke sini. So here, this is UI. Apa? Ramzan. UI apa ni? Muhammad Ramzan. I apa? Kalau at this point. At this point. This is J. At this point. Ramzan, are you here, Ramzan? I apa ni?
I minus 1.
I minus 1, comma, J dia level J. Ni kan sama level. Yang ni pun J. So kalau lah sini, daripada sini, that mean daripada sini kan, daripada sini sampai ke sini ni. So at this point is U, I plus 1, J. Boleh? Ni macam ni, yang macam ni.
Boleh.
Okay. So that mean yang ni kan, this is U, I, J. Sebenarnya, this is U, I minus 1, J. And this is U, I plus 1, J. Saya delete. This is U, I, J plus 1. And this is U, I, J minus 1. Okay. Okay, boleh. So sekarang, this is the yang biasanya nanti kita akan cari nilai dalam ni lah. Nilai dalam ni. So but then you have to know this one. Yang ni awak kena tahulah macam mana. Kiranya faham. Okay, you have to understand. Okay. So let's see. Okay. Daripada sini, I want to tell you, okay, finite difference methods, we can daripada formula itu, kita boleh sebenarnya guna forward, backward ataupun central. Awak ingat numerical differentiation chapter 5, okay? Kalau chapter 5, awak remember when we want to find the yang ni. Ni kan? Ingat tak? Numerical differentiations. Okay, untuk first derivative kita ada 2 point forward. Ingat tak? You remember tak? And we have 2 point backward. We have 3 point forward. Sorry. And we have 3 point backward. And we have 3 point central. Ingat. And F double prime, kita ada berapa? F double prime. Ingat lagi tak? Tersilap. Nurul Nazura. You still remember or not? In chapter 5. Chapter 5. Numerical differentiations. Ada second derivative ada berapa, Mak? Yes?
Kejap doktor.
Not remember? If you have book, you can turn to page, I think 100. Sekejap. Tengok.
Ada 3.
Ada 3. Ada apa? 3? Betul ke? 3. 3 method Apa Acu try cakap? Kalau ada table dalam buku page 122. Yes, Nurul Nazura. Kenapa ada yang keluar Syami? Dia takut saya tanya ke? Yes. Nurul Nazura. We have how many methods?
Yes.
Okay. So,
Ada 5.
ada 5?
Ada 2.
Okay, apa? Ada apa?
first derivative dengan second derivative.
Ya, sekarang adalah second derivative. Second derivative.
Oh, second derivative ada 3 point central dengan 5 point central.
Ya, okay.
Okay.
Thank you. Okay. Saja saya nak test. Okay, now, okay, since, okay, before this you learned we have forward, we have backward, we have central. So sebenarnya, actually in this finite different form, we can use forward, we can use backward, or we can use center as well. But, okay, but, kejap saya ataupun saya terang dulu macam mana backward, okay. Sekejap, go back to this one. If let's say, I take this one. Okay, I take one of this one value. Okay, saya ambil del U del T. Okay, del U del T dulu untuk yang heat equations. So let's say this one, we have del U del T. Okay, so this means this is a first derivative. And so first derivative tadi saya dah cakap, we have 2 point forward, 2 point backward, 3 point forward, 3 point backward. Okay, and so on. So based on kalau lah tadi yang saya lukis ni kan, kejap saya lukis balik. This one. Jadi, kalau tadi kan, we have here, yang ni adalah UIJ. This one is UI plus 1J. This one is UI minus 1J. Lepas tu kalau, okay. So this is, sorry, yang ni is T. Okay, yang ni kejap saya tukar. Saya ambil X. Okay, saya ambil del U del X. Sebab X, yang ni adalah paksi X. Okay, so I can use forward. Forward. Kalau forward, you go to the page 122, kalau sebelum ni kan, kalau forward, F prime, kalau 2 point, I take let's say this 2 point kan, approximate F X plus H minus Fx divide by H. Oh my god, saya terlupa sini. Yang ni saya cakap H, yang ni terlupa. Okay, yang ni terlupa. Tak apa. Sebelah sini, step size sini kita panggil H. Step size sini terlupa saya inform. Okay. Okay, this is the step size of T. If let's say sama ada tak kisahlah T ataupun Y, okay, we will use a symbol K supaya ada berbeza. So this one is H and this one is T. So this T that mean kalau sini kan dia punya step size J minus 1 divide by TJ. Okay. So tapi sekarang kita consider paksi X. Yang X saja. Yang this one. Ni macam ni. Okay. Daripada sini. Atas bawah tu kita tak kisah dulu. Okay. So this one. Okay. This is the 2 point forward difference that you learned in chapter 5 before. Now I want to change this one to kiranya adopt these equations. Cuma kat sini, because here we don't use X plus H. Fx tak ada. We use Uij. So that means yang ni adalah this one means like this. So this one, when we plus the step size, dia jadi yang macam ni. When we minus the step size, it become this one. Boleh faham tak? So when I want to change to finite different form, this one become del U del X become UI plus 1J minus UIJ divide by H. Boleh faham tak?
Boleh.
Okay. And now if let's say I want to use backward. Kalau lah let's say I want to use backward. Okay. Dalam kalau lah let's say you look in your previous chapter, in page 122, kalau lah 2 point backward dia macam ni kan. Fx minus F minus H divide by H. So sekarang, this one PDE we also can use backward. Kalau backward dia akan jadi macam ni lah. So dia punya U adalah U daripada belakang, daripada sini fx tolak yang belakang. Kan? So this one is ui j minus ui minus 1 j divide by h. Okay, ini boleh faham. Okay, so kalaulah second derivative, so far ini boleh. Tapi, okay, tapi ya, kita boleh guna forwards, kita boleh guna backward, and we can use center. Sekejap lagi, center tu lupa saya. Sekejap, center. Central. So, kalaulah 3-point central sebelum ni, in the previous chapter, like this the formula. This is H. 2H. So now, in PDE, it's become okay, macam ni. Boleh Okay. Kalaulah, if let's say second derivative, okay. Kalaulah T pun sama tau. Okay, let's say, okay, now is J. Yang macam ni. Kalau let's say, yang J punya, T lah, let's say this one. This one. Boleh faham so far? Okay. Siti Hamiza, okay or not? Siti Hamiza, okay?
Okay, Doctor.
Okay, let's say we want to find the partial derivative of u respect to t. Okay, t kan? T, remember I said this is based on, kalau kita lukis graph tadi kan, x, yang ni t. Dia macam, dia akan using the paksi y tu, t. Okay, so here, that means it will be like this. Saya padamkan ya. That means this one will be like this. Yang ni akan melibatkan this one. So kita akan melibatkan u, I, j, and this one is u, I, j minus 1. This is u, I, j plus 1. Okay. So when I want to do the first derivative of this one, so kalau ikutnya formula tadi, forwards, let's say this forward this one. Kalaulah forward punya, the final different form untuk del u del t become yang ni, x plus h. X plus h, maksudnya yang ni x kan, fx kan, plus h naik atas. So that means this one is become ui j plus 1 minus ui divide by, okay, sekarang tadi kita guna h, tapi kat sini kan saya terangkan, for this one, for the y-axis, we use the step size is equal to k. So here it's become k. Boleh. And if let's say we use backward, kalaulah backward, okay, that means like this. Sorry. uij minus uij minus 1 macam ni. Boleh Okay, tapi dalam awak punya syllabus sekarang, in your this one, explicit finite different form, and then all the finite different form untuk heat equation, wave equation and Laplace, kita biasanya guna secara forward. Yang forward saja, yang backward tu kita tak guna. Boleh So now this one is, you remember, kalaulah del u, del t, that means this is the finite difference form. Dia punya finite different form. Yang ni awak kena ingat. Boleh? Kalau awak teringat, you remember the concept. Okay, just now I said when this one is T, that means is at the exit Y. So exit Y, that means apa yang berubah adalah J. So awak tengok I is won't change. Ini tak habis saya tulis. Ini sepatutnya J. So yang ni awak tengok I ni kan tak berubah. Yang berubah ni J plus 1 minus J. Boleh. If let's say this one respect to T. Kalau Y pun sama. Okay. And this one is respect to X. Kalau X, awak tengok apa yang berubah adalah kita akan ambil I plus 1 minus I. UI ni. So yang J is still the same. Okay. So far okay? Yang ni adalah first derivative. Okay? If you are okay, then you type okay. If not okay, you type not okay. Pangkah okay lah. X okay. Where the others are now only got 41. Ada yang share komputer ke? Wait lah. Just now I got give you the sekejap saya copy balik yang attendance. Kita dah masuk dalam group WhatsApp awak sendiri. Wait, I paste this one. Ni. Okay, yang for those who haven't fill the Google form, please fill the Google form for as your attendance. Okay, sekejap untuk for the second partial pula. Okay, yang ni adalah first derivative kan. That means partial differential ataupun partial derivative of u. Sama ada respect to x ataupun respect to t. Kalau respect to y pun samalah. Dia pun macam ni juga. Okay, boleh. Maksudnya, kalau ini tak kisah ataupun del u, del y. Pun macam ni lah. Dia punya finite different form. Maksudnya macam ni sama. Okay, now if let's say we move to the second partial derivative of u respect to x katalah. Kalau macam ni. Okay. So kalau macam ni, dia second derivative. So sebenarnya you can see, tadi kan saya tanya apa? Kawan awak tu siapa? Nurul apa dah tanya? Nazura Nazura. Yang second derivative kita ada 3 point and 3 point center and 5 point center. So awak boleh je guna yang 3 point center punya formula. If let's say 3 point center, dia punya formula is like this. Fx minus h minus 2 fx plus with fx plus h divide by h square. So guna yang ni. So kalau sini, that mean this one can become, okay, sekarang boleh awak cakap dengan saya nak tulis apa? Kalau x minus h, yang ni adalah respect to x, respect to x. So saya kena tulis I apa yang ni? Kalau x minus h ni. U apa? Boleh cakap dengan saya tak? U apa? Tadi, yang ni, saya lukis yang tadi ni. Yang ni U, I, J. Kalau sini adalah U, I plus 1, J. Sebelah sini adalah U, I minus 1, J. So kat sini, Fx minus H. Gordon, you what? Gordon here?
Yes.
So we start with, if let's say X minus H. That means this one is U. Apa Nampaknya semua tak faham lagi ni. Herdiani. Betul, that's right, that's correct. No. UIJ UIJ yang sini. UIJ yang sini. Ikut je lah ni. Ni adalah UIJ ni. UI minus 1. Kau tulis minus 1 ke you tulis J? Minus J So that means we will start with UIJ. Kalau ikut ni. Okay. UI minus 1. Lepas tu minus 2 UIJ. Lepas tu yang ni plus. Yang ni kan dikira step size ni. Yang ni H. Yang ni pun H. That's mean daripada sini, okay, kurang sini. Yang ni tambah step size kepada ini. So that mean here is U, sini become U, I apa? IJ ke? Gordon?
Plus 1.
Yeah, plus 1. So this one is plus 1 and J. So here, this one is still H square sebab kalau X. Okay? Kalau this is, let's say, so this one, you have to remember. Ini awak kena ingat tau. Daripada this PDE punya, this, yang ni, equation ni macam mana, how we change to, this is finite difference form. Okay? Awak kena ingat, kena tahulah kiranya. So kalau lah second partial derivative, awak guna je 3-point center. Okay? Normally, okay, kalau lah keluar final ke apa, the formula yang ni tak bagi, yang ni tak bagi. This formula is not given. This formula is not given. Okay. But this formula is given. This formula is given. This one. Yang ni yang diberi. So that's why saya relatekan with this one yang chapter 5 numerical differentiation. Yang ni diberi tau. So ini awak tak perlu ingat. So macam mana how you change this one to find a different form. Okay. Kalau awak ingat terus, hafal terus, tak perlu pergi tengok pun lah. Okay. Now if let's say this one is del square U del T. So jadi macam mana? Respect to T. Sorry. Apa? Saya nak mula dengan apa? Saya nak panggil nama ni. Kan ada volunteer. Adib. Habiskan ini. So kalau respect to T, saya nak start dengan apa? You apa? Adib.
Ya, doktor.
Tahu tak? Nak start dengan apa ni?
Sekejap. Start dengan UI tolak J.
UI
1 tolak minus
minus
1J.
1J. Okay. Macam ni lah. Sekejap. Saya tulis cantik sikit. Tapi tak berapa.
Ya kot rasanya ke?
Okay. Tak apa. Ilham. Is it correct? Yang ni macam ni lah. So yang ni sama. Macam ni Adib. Ilham.
Yes, doctor.
Okay. Ilham. Betul tak? Agaknya.
I think so.
You think correct?
Yes.
Ada bantahan tak daripada kelas? Any of you? Ada? You can type. If you think not correct, then say not correct. You say correct, then you type correct. And then over apa? K square. Sebab ini T kan? Semua diam. Kenapa ni? Stress Saya nak make sure awak faham ke tak? Okay. Syami. Okay, I tell you. Okay, this one, ingat tadi kan? Saya lukis, ni X kan? X macam ni daripada UI. Sini UI minus 1. Sebelah sini UI plus 1. Kan yang ni T. T kan dia paksi. Y kan? So that mean dia punya yang ni panggilnya molecule graph tau. Yang ni panggil molecule. This one is UIJ. Dia naik turun atas dengan bawah lah. UI, yang ni J minus 1. Yang ni adalah UI J plus 1. Adib, betul ke Adib? So betul ke tak? So ini bukan. Because, okay, tengah tu betul lah, tengah tu. Yang tengah tu betul. Sebab ini terhadap T. T that mean dia terhadap yang J ni. J. Ingat lagi graf tadi saya kata ni kan. X ni T. So kalau X tu I yang berubah. Kalau T that mean J yang berubah. So kalau sini that mean kalau ini adalah tengah kan. UIJ. Kalau dia tambah step size, tambah H, dia akan jadi UIJ plus 1. Kalau dia tolak step size, that mean dia akan jadi UIJ minus 1. So kat sini, it become, here is UIJ minus 1. And this one is UIJ plus 1. Awak nampak at sini, apa yang berubah adalah J. Bukan lagi I. J minus 1, J plus 1. And this one is we use K for the step size. Sebab kenapa? Sebab dia T. Awak nampak dia T. Dia adalah T dipaksi Y kat sini. So dia atas dan bawah, bukan kiri kanan. If just now is X, kan? X is I. Kan ni, tadi ni. Oh. Tak boleh gerak lah pula. Oh. Ni kan, tadi ni X. So, when yang ni kan terhadap X. Yang ni terhadap X kan. Dia jadi yang terhadap I ni lah. So, apa yang berubah nampak? I minus 1 minus 2 UI plus UI plus 1. Sekarang boleh faham tak? Now understand or not? Adib, boleh?
Boleh.
Okay. Okay. So, sekejap. Saya tengok kepada. So, dah boleh. Kita continue. Saya tengok apa lagi saya belum. Okay. So, we start with the baru nak mula dengan heat equation. Okay, tadi saya explain how we change to the finite different form. So, kita sekarang start with the Parabolic PDE. So, kita start dengan heat equation. So, kalau heat equations, dia punya equation adalah macam ni. Second, partial derivative of u respect to x. Okay, minus 1 over c square. So, we will solve the PDE, okay, at point xi, tj. Inilah yang tadi, yang uij ni. Okay, yang ingat yang ada kiri, ada kanannya. This is ui minus 1 j. This is ui plus 1 j. Okay. So, and for the PDE, okay, we start with the first method. Explicit finite different methods. For the explicit finite different method, we will use, we call it forward time central space finite difference method. Kalau ini dia punya short form is FTCS lah. Maksudnya forward. Guna forward. Tadi kan, just now I explained to you, we can change to finite different form. Forward secara yang forward punya 2 point forward, 2 point backward, and even 3 point center. Okay, boleh 3 ni kan. So ini, and why is time? Because this heat equation we have dt based on time tu lah. Okay, kalau lah now, okay, saya nak change, okay, let's say saya tulis balik lah dia punya equations daripada yang ni. It can be I put this del u del t to the one is the left side, one is on the right side. Saya letak del u del t. Okay, so we will solve at xi tj c square second partial derivative of u respect to x. So untuk di titik start xi tj. Okay. So sekarang kejap kalau saya nak ubah kepada finite different form, sekali lagi tadi yang kita dah belajar just now, this one, macam mana dah? Kelas tadi jadi apa? I'll see this one is respect to t. So that means tadi first derivative we can use 2 point forward tu kan? 2 point forward u apa? Habis sekali ni. ui apa?
J plus 1.
Yes, j plus 1 minus uij divide by k. Betul. Equal to c square. So this one is second partial derivative of u respect to x. So ini akan jadi, kita akan guna 3 point central second derivative tu. So that means this one ui minus 1 j minus 2 ui j plus ui plus 1 j divide by h square. Boleh? Okay. And then when we have this one, so we have to substitute the value of k, the step size, of t, the step size of x, okay? Lepas tu kalau ada value here, we have to put lah. If let's say this one, so and then we have to solve. And if you look at this one, we have berapa dia punya dia punya u tu. We have uij plus 1. Let's say, saya lukis kalau katalah ini adalah uij plus 1. Okay. So maksudnya, and then the second one is kita ada this one, uij. Maksudnya bawah dia lah kan. So we have this one, uij. Lepas tu continue. We have this one, ui minus 1j. Kita ada sini pula, ui minus 1j. Lepas tu we have uij, dua ni kat sini. And this one, ui plus 1j. This one, ui plus 1j. Okay. So, kita ada yang ni. This we call as molecule graph. Okay. So, sebenarnya yang ni yang kita nak cari. uij plus 1. This is our target cell. The value that we want to find. Okay, let's say, okay tak? Kelas, okay. Nur Ain, okay, Nur Ain. Boleh faham tak? So, kalau lah, let's say, so now since I mentioned just now, what we want is uij plus 1. So when these equations, the equations, I will try to put uij plus 1 to the left and the rest put on the right. Okay, so kalau lah daripada ini kan, saya jadikan uij plus 1 equal to, saya bawa k tu ke sana, jadi kc square over h. Saya keluarkan h. H square, sorry. Become ui minus 1j minus 2ui plus ui plus 1j. Lepas tu plus with uij. Kan? Yang uij ni saya bawa ke kanan. I bring to the right. Now, so kalau lah let's say, if you want still to assume nak simplify kan lagi. Tapi saya akan biasanya in my students, I will just ask them to do like this. Simplify dengan gabungkan. After you key in the value of k and h, gabungkan simplify the uij ni. Kalau let's say you want to simplify again, let's say we take r is equal to kc square over h square. So this one will become uij plus 1 equal to r ui minus 1j plus with, here we have, because here we have 1 uij, and this one is minus 2. So become this one 1 minus 2r uij plus with r ui plus 1j. Sekejap. Sampai sini boleh faham ke tak? Can you understand? Okay. If you cannot follow, you just let me know. Boleh?
Boleh.
Okay.
Satu
Now,
tolak dua pada mana?
huh?
Betul? Satu tu tolak dua R
1 tolak 2R kat sini. Since, okay, yang ni saya dah jadikan R kan? This one, the whole thing. Ke mana saya punya ni? This one. Yang ni dah jadikan R ni. Saya jadikan R kat sini. Ke mana saya punya ni kan? Yang ni kan saya dah jadikan R kat sini. Ni kan? Jadi masukkan maksudnya sini sama dengan R ui minus 1j minus 2uij plus ui plus 1j tutup kurungan plus uij. So sekarang saya ambil yang ni. Okay, saya ambil yang uij ui minus 1j. Keluarkan. So dia darab dengan R kan? So dapat yang ni. Dapat yang ni. Okay, boleh?
Okay.
So yang kedua, yang ni kan ada uij ni. Yang ni 1, sini 1 kan? Tapi yang ni adalah 1. Tolak dengan yang ni R darab dengan 2, negatif 2 ni. So jadi 1 tolak dengan 1 negatif 2R. 1 tolak 2R. Yang ni kan 2 darab R ke depan ni. Boleh faham?
Okay.
Boleh. And now this one is, third one, this one. This one, kita darab dengan R depan. So become RU. Boleh? Boleh. Awak tak tukar macam ni pun tak apa. Okay. Why I say like that? Because normally in the finite it won't give you macam ni. Maksudnya awak kena simplify sendirilah. Okay. So, now, kalau saya lukis balik kan, tadi kan, molecule graph tu. This is uij plus 1 kan. Saya akan, yang ni akan ada Ni kan, ni kalau sini, sorry, saya sepatutnya bukan. Dia silap. Saya sepatutnya tulis yang ni betul target cell. Saya ini adalah target cell saya, UIJ plus 1. Kalau tengok sini UI, sini adalah 1 tolak 2R. This is UIJ kan. Yang ni apa? Yang ni adalah sorry. Bukan. R. Saya akan masukkan nilai R kat sini. Yang ni adalah maksudnya UI plus 1J ini. And here we have another one is here. R. And this is UI minus 1J. So maksudnya UI J plus 1 is equal to R darab dengan this UI minus 1J tambah dengan 1 tolak 2R, 1 minus 2R, UIJ plus with R time with UI plus 1J. Boleh faham tak? So I can put this one in calculator. Nanti saya akan letakkan, I will put this one as A, B, C. Lagi senang. The value. Semua blur. Boleh sempat lah kita pergi example. Mungkin awak boleh faham. Sekarang, okay. Well, faham. Now you understand how we get from this one, this equation, okay, to this molecule graph or not? Macam mana pergi ni, boleh faham tak? Ni kan? Ni yang apa yang kita nak? UI minus 1. This is the ni nanti kita akan cari nilai ini. Setiap kali kita akan cari nilai ni, this one. And yang ni, this one. R ni adalah sini. Ni kan? Nampak? R. Lepas tu, this is one minus 2R adalah UIJ. Okay. And then R here, sebenarnya this one. Yang ni adalah constant. Maksudnya constant. Kiranya constant yang saya akan darab to that particular akan setiap kali ni, okay, macam ni. Mungkin saya lukis bagi awak. Sekarang ni awak macam blur, dah faham lagi ni. Kenapa? Why this molecule graph is very important? You remember just now I said we will have to solve the value kat sini kan. This is T. Okay. Yang ni kan kita ada nilai sini, ada nilai sini. We have this value at this line. Okay. And we have this value at this line. Okay. So that means we have to find the value is over here, right? Ni kan? Okay, saya lukis jadi molecule graph macam ni, boleh faham kalau ni. Satu. Boleh faham? So ni adalah ni target cell. Nilai yang saya akan nak cari. U, I, J plus 1 ni. Boleh. And after we get this one, saya akan injakkan saya punya molecule graph kepada sini pula. This one, di mana this one is become my UIJ, lepas tu sebelah sini adalah UI minus 1, sebelah sini pula. So, I will find this value. Saya akan cari nilai ni pula. Boleh faham tak? So, kita akan gerak. That means we have to move this molecule graph. So, the next one is, that means I have to move to the right. Yang ni, UIJ plus 1. Yang ni turun ke bawah, UIJ. Ke kanan sini, this is the UI plus 1J. And this is UI minus 1J. Where all of this value at this value, ini X kan kita akan, we already have this value. So that means we only need to find this one. Untuk heat equation. Boleh?
Boleh, Doktor.
Okay. So nak stop sini ke sambung next class? Boleh?
Ya.
Ada setengah jam lagi. Nak stop kat sini ke nak sambung next class? Nak sambung saja. Masih boleh? If let's say, okay, kalau nak continue, then you type 1. If you don't want to continue, we continue next class, we type 2. Macam half-half lagi tu. Ada yang masih okay ya. Okay. So, okay. Never mind. We continue tomorrow kan? Kelas kita. Tomorrow 2, right? Okay.
Ya betul.
Okay. So, we continue tomorrow with the example of heat equations. Okay. So, yang ni awak kena, kalau awak ingatlah, awak kena ingat ini. So, and then we continue example heat equation tomorrow. And tomorrow we will use the same link, Google Meet link. This one, same Google Meet link. If let's say, kalau lah saya akan lewat, nanti saya akan inform lah kepada Dr. To atau Adib lah. Saya bagi tahu Adib pun boleh. If let's say I need to start our class, postpone pukul 2.15 ke, and then I will inform. Okay, from now kita start from 2. So tomorrow at 2 p.m. still you again. Let's stop. So far semua dah ambil attendance ke?